Welcome to my kcse vision channel. I am teacher James Marita, Creole Boys High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision from one work, and our topic is the questions on heating and cooling curves. So in heating and cooling curves, although in my diagram here I don't have the cooling curve, so this one represents the heating curve of a substance. So the following graph shows what happens when a solid was heated until it melts. So we are supposed to study this one and then we answer the questions. You can see now the solid was heated and this solid it melts. It melts at 100 degrees, and then there is a boiling at 200 degrees. So we have this scale which is 50, 100. This is where we have the melting point, and then we have 150, 200. This is where we have the boiling point of this substance. So this curve, it normally represents the heating of a pure solid. Pure solids normally they have a sharp melting and boiling points. So what is the melting point of this substance? The melting point of this substance, as you can see, it just melts at 100 degrees. So this is where we have the melting point of this substance. It just melts at 100 degrees. So what is the boiling point of the substance? As you can see, the boiling of this substance, it boils at 200. So we have the boiling point of this substance, it normally boils at 200. So we have a melting point at 100 degrees, and then we have a boiling point at 200 degrees. How long does it take for the substance to melt completely? For this substance to melt completely, it just takes 5 minutes, as you can see. So it just takes 5 minutes for this substance to melt completely. Was the solid pure or impure? Then we are supposed to explain. To understand whether the heating substance is pure or impure, you check on the shape of the curve. The shape of the graph in that case, it has a sharp melting and boiling points. So when we have a sharp melting and boiling points, it means that the substance is a pure substance or it is just a pure solid. But when we don't have the sharp melting and boiling point, for example, here you can have another graph of this kind. We have another graph of this kind here. So if you compare these two graphs, it means this one here we don't have the sharp melting and boiling points. So this one normally represents an impure solid. So this one represents the pure solid, or you can say that it represents a pure substance. But where we have a sharp melting, and a boiling point like this one, it indicates that the substance is just a pure substance. So this one indicates a graph of a pure solid, or you can just say it is a pure substance. So sometimes you will be asked now to draw a graph of a pure substance. So an impure substance normally they don't have the sharp melting and boiling points, whereas the pure substance it has the sharp melting and boiling points. That is how you can differentiate between the two graphs. Now, there is another one here that the curve shown below was obtained when a pure naphthalene was heated to boiling. So you can see from the screen that this one is a pure naphthalene, because on this graph we have a sharp melting and boiling points of this naphthalene. So this one indicates the heating of a pure naphthalene. Now we have, what is the effect of do you give to the curve shown in this graph? So normally the curve which is given, the title given to this curve, when it starts from this point upwards here, it is normally called the heating curve. So here we have, this is the heating curve. We have the cooling curve, which starts from the top here and then it comes down. But when it comes from, for example, this one starts from 0 degrees all the way up to 200. This one indicates the heating curve. We have the cooling curve, whereby now it will start from 200 and then the temperature drops until it is 0. We call that one the cooling curve. So the correct title given to this curve is heating curve. Then explain in terms of kinetic theory the process occurring PC. In terms of kinetic theory, the process occurring at PC. If you can check on this graph at AP, the temperature is rising steadily because there is again in kinetic energy. So we have in the PC, in that case, the temperature remains constant. We are going to see what's happening there. It is because the heat energy or the energy obtained at AP is used to break the intermolecular forces holding the particles together, and in that point now there is a change of state from being a solid state to a liquid state. And again at CD, the temperature rises steadily, as you can see. Then this DE, that temperature remains constant because the energy gained at CD is used to break the molecular forces holding the particles of the liquid together. So at this point, the liquid will change their state to a gaseous state. So in terms of kinetic theory, at PC, as you can see, the temperature remains constant. The temperature remains constant, so the heat absorbed is used to weaken the forces of attraction holding the particles together. At this point, there is a change of state from a solid. There is a change of state from a solid to liquid. Give one industry application of the effect of impurities on the substance, on the effect of the impurity on the substance. Impurities are a substance which are added to a substance. It normally lowers the boiling point. It lowers the melting point of a substance and also increases the boiling point of a substance. Likes of sodium chloride salt is a substance which is acting as an impurity, and therefore if added to a substance, it normally lowers the boiling point of a substance and it lowers the melting point of a substance and it increases the boiling point of a substance. So what is the application where a salt is being added, either to lower the melting point or increase the boiling point of a substance? So in that case, we say that lowering the melting point of ores during the extraction of metals. So during the extraction of metal, for example, the extraction of sodium metal, it has a high melting point. So a certain salt is added to lower the melting point. So that salt which is added to the ores of that sodium chloride, it is a calcium chloride. Calcium chloride, if added to the ores of sodium chloride, which is an ore containing sodium metal, it normally lowers the melting point of that metal. So a salt is poured on the rods to lower the freezing point of water, and this prevents the ice from forming on the roads. But understand also this one, it has a long-term effect on the motorist, whereby it normally causes corrosion or rusting of the parts of that motorist, where some parts of the motorist which is made up of the iron metal. So once that parts of it comes in contact frequently on the roads, it can normally get rusted. So that is the long-term effect of the use of this salt which is spread on the roads in this case to reduce the smoke. The diagram below shows the heating curve of a pure substance. So you can have this pure substance. We have a pure substance. We have a process A, P, which is W, then PC, you can see there, CD like that. So as you can see, the melting point of this substance is melt at 100 degrees. So the melting point of this substance melt at 100 degrees. And the boiling point of this substance it boils at 200 degrees. So this one, of course, it is not water because water boils at 100 degrees. And in this case now, if you will be asked if why this substance is not water, because the melting point and the boiling point of this substance is normally above that of water. And as you can see now, this is a bigger substance because it has the sharp melting and boiling points. So what are the physical states of a substance at point X? At the point W, the physical state of this substance at this point here, it is just solid. So we call this one here, this is just solid. At X, at X here, at point X here, we have it is solid liquid. This is where there is a change of state. Because the energy observed at LP, it is used to weaken the molecular forces holding the particles of the solid together. So at that point, there is a change of state of a solid to a liquid. And that is why in that state, PC, the state of that substance is just solid liquid because there is a change of state. At the point Y, we have that one is as a liquid, we have at point Y as a liquid, and then at the point Z here, we have the state of that, the physical state of that substance. At the point Z is just a gaseous state. What happens to the temperature between PC? As you can see that PC, what is happening there physically, as you can see. What is happening here in PC, the temperature remains constant. And the reason why the temperature remains constant, it is because the heat energy absorbed at AP, it is used to weaken the molecular forces holding the particles together. At that point now, there is a change of state from a solid to a liquid state. The substance under test is not water. Give a reason for this. So the substance which is under test is not water because the boiling point, it boils at 200 degrees and then it melts at 100 degrees. So you can just say it is melting point and the boiling point is above that of water. Water boils at 100 degrees, water boils at 100 degrees and water melts at 100 degrees. Water melts at 0 degrees and it boils at 100 degrees. But if you see this one, it melts at 100 degrees and then it boils at 200 degrees. So the substance tested is normally not water. What will happen to the melting point of this substance if it is contaminated with sodium chloride? Sodium chloride, it is a salt, and the effect of a salt on a substance, it normally lowers the melting point of a substance, and then it increases the boiling point of a substance. So what happens here, the melting point of this substance will just decrease as simple as that. The diagram shows the heating curve of a pure substance. So we have a pure substance here. You can see it is a pure substance because it has a sharp melting and boiling points. And again, as you can see, this substance is not water. The substance being tested is not water. Why? Because the melting point of this substance is 115 degrees. And it boils at a temperature of 444 degrees. So you can see the melting point and the boiling point of this substance is above that of water, therefore it cannot be water at all. What physical changes takes place at point X and Z? At the point X and Z, the physical changes takes place at here, it is just melting. That is where we have melting. The solid will melt, and therefore there is a change of state from a solid to a liquid. Then we have at point Y here, it is just boiling. There is a change of state whereby there is a change of state there is a change of state, the temperature is rising, so there is a gain of energy which is used to weaken the molecular forces. Therefore, what is happening there is just boiling. Explain what happens to the melting point if sodium chloride is added to the substance. It is the same thing that we have already said, that the melting point decreases as sodium chloride is an impurity which lowers the melting point of a substance. So sometimes you will be required also to draw the cooling curve. Cooling curve, if you are required now to draw the cooling curve normally starts like this one. So we have if you are required to have a cooling curve, so if you are drawing a cooling curve, so that is how you can draw. This is a cooling curve. Of course, you will have and this is temperature, and then you will have this one here. It is time. And then we can have time in normally given time and you have that time in minutes. So if you are required to draw a cooling curve normally starts from the above here where we have condensation. So we have the condensation. This is where we have condensation is here. So you indicate that this one is condensation. There is condensation there. There is once we have that condensation at that point, we have the freezing. So you can have freezing here. So we have this one is just freezing. So this is a simple diagram on how you can represent the cooling curve. So the cooling curve will start from the highest temperature and then the temperature drops because that substance is being cooling. And as you can see, this is the cooling curve of a pure substance. This one is a pure substance. This one is for pure substance. You might also be required to indicate the cooling curve of an impure substance. An impure substance normally does not have, so this is an impure substance. So you indicate this is the impure. So we have this is impure substance. The impure substance normally do not have the sharp melting and boiling points. That's how you can distinguish between impure substance and of course the pure substance. We have come to the end of our lesson. All the possible questions that can be sent from the cooling and the heating curves. Don't forget to subscribe to my channel, watch and share. Thank you.